Hello, my cherished viewers. You are all welcome back to this channel. Prof. 1 Tutorials is here again. Today we are going to continue with WASSCE 2025 Elective Math. In my previous video, we looked at the compulsory aspect from question 1 to question 8. And today we want to continue from question 9. So keep in touch. You can pick your notebooks, pen, pencils, calculators as we go through the questions step by step. So stay tuned, my fellow viewers. WASSCE 2025. Elective Mathematics. Question 9. Given that (10/7) into bracket n combination 6, comma, n combination 7, comma, and n combination 8 are the first three consecutive terms of an exponential sequence into bracket GP. Find the A value of n, B common ratio of the sequence, C sum of the first (13) terms of the sequence. Alright, so my cherished viewers, this was the question 9 for WASSCE 2025. So we're going to look at how we can get the value of n, the common ratio, as well as the sum of the first 13 terms. So now let's begin. So we have 10/7 in a bracket, n combination 6. We have n combination 7. We have n combination 8. Now the question said, are the first three consecutive terms of an exponential sequence, or GP, where GP means geometric progression. Now over here, we are going to simplify the combination before we can find the value of n. So now let's start with the simplification. So we have n combination 6. So with combination, we always take the n factorial over n minus 6 factorial, still multiplying 6 factorial. So now we are going to expand them. So before that, let's deal with the n minus. So we are going to continue with n combination 7. So n combination 7 is also giving us n factorial all over n minus 7 factorial. Then we have 7 factorial. Then we have n combination 8, which is also equal to n factorial all over n minus 8 factorial, then 8 factorial. Now, because we are dealing with exponential sequence or the geometric progression, then this divided by this is the same as this dividing this. Okay. So n combination 8 all over n combination 7 is equal to n combination 7 all over 10 over 7 multiplying n combination 6. All right. So now from here, n combination 8 is what we have here, which is n factorial all over n minus 8 factorial, 8 factorial, dividing n combination 7, which is also this, n factorial all over n minus 7 factorial, then we have 7 factorial. Now we know that anytime we are dividing two fractions, we are going to maintain the first one. So we have n factorial all over n minus 8 factorial, 8 factorial. Then the division sign changes to multiplication. This moves up, then this one will come down, giving us n minus 7 factorial, 7 factorial all over n factorial. Now, this can cancel this. And again, we can still deal with this. We can still deal with this. So from here, n minus 7 factorial is the same as so we have 1 over n minus 8 factorial, 8 factorial, multiplying. Now, anytime we are dealing with factorial, for example, 9 factorial is the same as, when you want to find 9 factorial, we always start with the number given. So it's going to be 9 multiplying difference of 9, difference 1 of 9, which is 8, multiplying difference 1 of 8, 7, multiplying difference 1 of 7, we have 6, multiplying difference 1 of 6, we have 5, multiplying difference 1 of 5, we have 4, multiplying 3, multiplying 2, multiplying 1. This is how we find 9 factorial. So if we are to find n minus 7 factorial, then we are going to start with the n minus 7. So n minus 7 will be repeated. Then difference 1 of n minus 7, we have n minus 8. And this is where I will end. because I have here to be n minus 8 factorial, which can help us to cancel out. So multiplying 7 factorial all over 1. Because this and this has been cancelled out. So from here, n minus 8 factorial, we take off n minus 8 factorial. So we have 1 over 8 factorial. But we know that 8 factorial is the same as 8 times 7 factorial. Multiplying n minus 7 multiplying 7 factorial all over 1. So from here, this can also cancel this. So it will be left with 1 times n minus 7. We still have n minus 7 over 8 to be n combination 8 factorial n combination 8 dividing n combination 7. So this time we are going to deal with n combination 7 also dividing 10 over 7 multiplying n combination 6. So now we are moving on. So we have n combination 7 all over 10 over 7 multiplying n combination 6. Now we all know that n combination 7 is the same as n factorial over n minus 7 factorial multiplying 7 factorial divided by 10 over 7 into bracket n combination 6, which is also the same as n factorial over n minus 6 factorial multiplying 6 factorial. So from here, this is two fractions divided. So we are going to maintain the first one, change the division to multiplication, and then reciprocate this whole fraction. So we have n factorial all over n minus 7 factorial, 7 factorial times. Now the moment I bring the multiplication, everything beneath will move up. So we are going to get 7 into bracket n minus 6 factorial, 6 factorial all over 10 multiplying n factorial. So quickly, this can cancel this. So now we are going to move on with the simplification. So we have 1 over n minus 7 factorial multiplying 7 factorial times 7 into bracket. Now n minus 6 factorial is the same as, so we are going to first of all write n minus 6. Then the next term is going to be n minus 6 minus 1, giving us n minus 7 factorial, so that we can use it to cancel what we have here. Then 6 factorial all over, so this is 6 factorial all over 10. So from here, this can take off this. So now we have 1 over. Now we know that 7 factorial is the same as 7 multiplying 6 factorial times 7 into bracket n minus 6, then 6 factorial all over 10. So here 6 factorial will cancel 6 factorial. Then we are going to get 1 multiplying 7 into bracket n minus 6. So we have 7 into bracket n minus 6. Because 1 times anything here, we still have the same thing. All over 7 also multiplying 10. So from here, this can also take off this. So now we are going to be left with n minus 6 all over 10. And this is the answer we had from n combination 7 all over 10 over 7 multiplying n combination 6. From the onset, we said that n combination 8 over, so let me write it here. So n combination 8 over n combination 7 should be equal to n combination 7 all over 10 over 7 multiplying n combination 6. And from our calculations, n combination 8 all over n combination 7, we had n minus 7 all over 8. So this dividing this is what we had. And then n combination 7 all over 10 over 7 multiplying n combination 6, we have n minus 6 all over 10. N minus 6 all over 10. So from here we can get the value of n from here. And what you are going to do is to cross multiply. So we have 10 multiplying n minus 7 is equal to 8, also multiplying n minus 6. So here we are going to expand the bracket. 10 times n, we have 10n minus 10 times 7, we are going to get 70, which is equal to 8 times n, we have 8n minus 8 times 6, we have 48. So my fellow viewers, when you get here, you are going to group like tens. So we have 10n. The additive inverse of positive 8 is negative 8n, which is equal to negative 48, and additive inverse of negative 70 is positive 70. So now 10n minus 8n, we have 2n, which is equal to, and minus 48 plus 70, we have 22. So from here, we are going to divide through by the coefficient of n. So this side over 2, this side over 2. This will take off this, and n is equal to 11. So this was the value of n. Now, when you check the B part of the question said we should find the common ratio. And we know that this over this can be used to find the common ratio. So R is equal to n combination 8 all over n combination 7. And after evaluating this, we had n minus 7 over 8. So this is the same as n minus 7 over 8. And we know the value of n to be 11. So we have 11 minus 7 over 8. And 11 minus 7, we have 4 over 8. And when we simplify further, we are getting 1 over 2 to be the common ratio. So this will be your common ratio, R. So now let's look at the last part of the question. So we have C. Sum of the first 13 terms of the sequence. All right. Under GP, generally, the sum of the first n terms is giving us A into brackets 1 minus R exponent n all over 1 minus R. And we are using this because the common ratio we have here is less than 1. So now we have sum of first 13 terms to be equal to. Now from here, the question was very clear about the terms. If you remember, we were given the terms to be 10 over 7 in a big bracket, n combination 6, then n combination 7, then n combination 8. And the question said these are the first 3 consecutive terms. This means that this will be our first term. So here, the first term is n, the first, so from here the first term is 10 over 7 multiplying 11 combination 6. And I'm using 11 here because we had the value of n to be 11. So here 10 multiplying 11 combination 6. What did you get? So we have 10 over 7 multiplying 11 combination 6. So you can use a calculator to try. 11 combination 6, what did you get? 462. Good. 462. So from here, this 7 goes here 1. 7 goes into 462 66 times. So we have 10 times 66 and we are getting 660. So this 660 will be your first term A. So after getting the first term, then we can fix it here. So we have 660 into bracket 1 minus R exponent n. And we know that our R is 1 over 2. So we have half exponent n, and the n is 13. Because the question said sum of the first 13 terms all over 1 minus half, because we still have the R to be half. All right. So we have S subscript 13 to be 660 in a big bracket 1 minus. Now we have 1 over 2 all power 13, and you're going to get 1 over 8192 all over. Then we have 1 minus half. We are going to get half. So we have 660 multiplying 1 minus 1 over 8192 we are going to get 8191 all over 8192 all over half. So from here, we are going to multiply 660 by the fraction we have here. So 660 multiplying 8191 all over 8192. What did you get from your calculator? So we are going to get 540606060 all over, with the same denominator, have 8192 divided by 1 over 2. So from here we are going to get 5406060 all over 8192 times, and because this one is a fraction, we are going to take the reciprocal, which is 2 over 1. So now this times 2 over 1, we are going to get 1319.838867, and this will be the sum of the first 13 times as 13. So from here we are going to correct to 4 decimal places. So we have 1319.8389, and this will be the final answer for the question 9. So we are going to look at the question 10 quickly. Question 10A. Without using calculator or mathematical tables, evaluate 3 all over 2 minus root 3 minus 2 over 2 plus root 3, leaving the answer in the form m plus n root 3, where m and n are real numbers. So we have 3 over 2 minus root 3 minus 2 over 2 plus root 3. So from here, we are going to take them one after the other. So now I'm going to start with 3 over 2 minus root 3. Then I will just evaluate this without using a calculator or tables. Because the denominator is in a form of a surd, then I need to rationalize. In rationalizing, I will multiply the numerator by 2 plus root 3 and the denominator by 2 plus root 3. So at this point, I'm going to multiply both the numerator and the denominator by 2 plus root 3. So from here, 3 times 2, we have 6 plus 3 times root 3, we have 3 root 3 all over. Then 2 minus root 3 multiplying 2 plus root 3. This is a very simple trick. Pick the one with the negative. So we have 2 squared minus root 3 squared. Always pick the one with the negative, square the first term, then you square the second term. This is because this is the same as 2 minus root 3 multiplying 2 plus root 3 from an idea of difference of two squares. So here, difference of two squares is the same as 2 minus 3 multiplying 2 plus root 3. So we have 6 plus 3 root 3 all over. From here we know that 2 squared, we have 4 minus root 3 all squared, we are having 3. So we are going to get 6 plus 3 root 3 all over 1. And 6 plus 3 root 3 all over 1, we are still going to get 6 plus 3 root 3. So we still have 6 plus 3 root 3 to be the evaluation for the first one. So now let's deal with the second part, which is 2 over 2 plus root 3. Now at this point, we are still going to rationalize. In rationalizing, we are going to multiply the numerator by 2 minus root 3 all over the denominator also by 2 minus root 3. 2 minus root 3. So from here, 2 times 2, we are going to get 4 minus 2 times root 3, we have 2 root 3 all over. And here, we are still going to pick the idea we spoke about earlier. So here, I will take the one with the minus, square the first term, and then I will square the second term. This makes it much more simpler and easier. So I have 4 minus 2 root 3 all over 2 squared, we have 4 minus root 3 all squared, we have positive 3. So we have 4 minus 2 root 3 all over 4 minus 3, we have 1. And we know that 4 minus 2 root 3 over 1, we are still going to get the same answer, which is 4 minus 2 root 3. But the question was this minus this. And this we had the answer we have here. This we have this answer. So we are just going to take the difference. So it's 3 over 2 minus root 3 minus 2 over 2 plus root 3. So from here, 3 over 2 minus root 3, we had 6 plus 3 root 3 minus, we also have here to be 4 minus 2 root 3. Then this will give us 6 plus 3 root 3. When the negative affects the 4, we have minus 4. And negative, negative, we have positive. po. So positive 2 over 3. So at this point, we are going to group like terms. So we have 6 minus 4 plus 3 root 3 plus 2 root 3. So my cherished viewers, for 6 minus 4, we have 2 plus 3 root 3 plus 2 root 3. So 3 plus 2, we have 5. And we pick one of the roots. So this was the final answer for question 10A. Now let's look at question 10B. Question 10B. Given that the integral with lower limit -2, upper limit m, with a function 4x squared minus 2x plus 9 dx is equal to 172 over 3, where m is an integer. Find the value of m. So from here, we are going to evaluate this. Then after that, we make substitution and get the value of m. So let's start. So from here, we are going to integrate the function straight away because we have limit. We have the lower limit as well as the upper limit. In integrating what we have from the bracket, 4x squared, when we want to integrate 4x squared, it's going to be 4x squared. You just add 1 to the exponent divided by the same thing from the exponent, which is 2 plus 1, minus 2x. We all know that the x here has power 1. So I'll just add 1 to it. So plus 1 all over the same thing from the exponent 1 plus 1. Plus, when I am integrating any constant, then I will just add a variable to it. Because it is with respect to x, I'm going to add x to it. Then we have the limit to be m and then -2, and everything has been equated to 172 all over 3. So now let's simplify what we have here. We have 4x exponent 2 plus 1, which is 3. So we have 4x cubed all over 3 minus, here we are going to get 2x, 1 plus 1, we have 2. So we have 2x squared all over 2 plus, and over here we have 9x. So 9x, still with the limit m to -2, and it has been equated to 172 all over 3. 172 all over 3. When we get here, we are going to make substitution. So we have 4 into brackets. Now we are going to substitute the upper limit first. So anywhere we see x, we are going to put m there. So we have m cubed all over 3 minus 2 into bracket m squared all over 2 plus 9 multiplying m. And this is the substitution of the upper limit. After making substitution of the upper limit, then minus, we now substitute the lower limit, which will also be equal to 4 into bracket negative 2 power 3 all over 3 minus 2 into bracket negative 2 power 2 all over 2 plus we have 9x. So we are still going to substitute the negative 2 in it. Now plus 9 multiplying negative 2, which is still, everything is equal to the fraction we have here. 172 all over 3. So now we are going to take it step by step. Before that, 2 here will cancel this 2 again. This 2 will also take off this 2. So from the first term, we are going to get 4m cubed all over 3 minus, we have here to be m squared, we have here to be plus 9m minus bracket open. So let's look at this. So here we have 4 multiplying negative 2 cube will give us negative 8 all over 3 minus, we have negative 2 all squared, we have positive 4 minus 9 times negative 2, we have negative 18, which is still equal to 172 all over 3. So we are still simplifying. So we have 4m cubed over 3 minus m squared plus 9m minus another bracket 4 times negative 8, we have negative 32 over 3. Then here we have minus 4 minus 18, and we are going to get negative 22, which is still equal to 172 all over 3. We are still moving on. So we have 4m cubed all over 3 minus m squared plus 9m. And here, the negative will affect the first one we have, positive 32 over 3. Then, this negative will also affect the second one. We have positive 22, which is still equal to 172 over 3. All right. So when we get here, we are going to find the LCM and multiply each term by the LCM. So from here, the LCM is 3. So you are going to multiply each term by 3. So we have 3 times 4m cubed over 3 minus 3 times m squared plus 3 times 9m plus 3 times 32 over 3 plus 3 times, the next one is 22, is equal to 3 times 172 all over 3. So from here, this can cancel this. This can also cancel this. This can also cancel this. So now we are going to evaluate them. So we have 4m cubed, and here we have minus 3m squared. So minus 3m squared. Then 9 times 3 times 9m, we have positive 27m. And here the 3 here has cancelled out the denominator. We have positive 32 plus 3 times 22, we have 66, which is equal to 172, because the 3 here has taken off the 3 we have there. So from here, we are going to group like terms. So we have 4m cubed minus 3m squared plus 27m. So we have 32 plus 66. We have 98. Then this 172, we are going to take the additive inverse, which is negative 172, which is still equal to 0. So now we have 4m cubed minus 3m squared plus 27m. And 98 minus 172, so we have negative 74, which is equal to 0. Now, when you get here, we need to get one factor which can divide this completely. So we are going to get a factor which can divide this one completely. So from this polynomial function, m minus 2 is a factor. So we are going to use m minus 2 to divide this whole function. So we have m minus 2 dividing 4m cubed minus 3m squared plus 27m minus 74. So when m divides 4m cubed, we have 4m squared. Then this m will multiply the 4m squared. We have 4m cubed. Negative 2 times 4m squared. We have negative 8m squared. So here we are going to take the difference. So here minus 3m squared minus 8m squared. We have 5m squared. Then we drop one of the times, which is positive 27m. This m will divide the 5m squared. We have positive 5m. M times 5m, we have 5m squared. Negative 2 times 5m, we have negative 10m. We are still taking the difference. So here we have 27m minus 10m. So we have 37m. Then we drop minus 74. When m divides the 37m, we have positive 37. M times 37 we have 37m. Then negative 2 times 37 we have negative 74. And when you take the difference, everything will move 0. So this means that this whole thing is the same as m minus 2 multiplying 4m squared plus 5m plus 37. So we have m minus 2 multiplying 4m squared plus 5m plus 37. Everything is equal to 0. Now from here, let's check if we are going to get a distinct root, equal root, or a complex root. So in checking this, we can use the discriminant, which is b squared minus 4ac. So from here, my a is equal to 4, my b is equal to 5, my c is equal to 37. So here I am going to get 5 squared minus 4 multiplying a. And I have a to be 4, I have c to be 37. So I have 25 minus 4 times 4 times 37. I have 592. And 25 minus 592, I am going to get negative 567. And because the discriminant is less than 0, then everything here is going to be a complex root. So because of that, then we can say that m minus 2 is equal to 0, where m is equal to 2. Because the question said where m is an integer. So therefore, m is equal to 2. So we are going to end here and continue in our next video. Keep in touch. Bye.